STS-30 Lockheed Orbiter Test Director Mike Key polled all of the various test conductors and verified there are no violations of launch commit criteria at this time. The only thing which we continue to watch is not expected to be a problem is the temperature of a water spray boiler. Astronaut support person Bruce Melnick has also cleared the orbiter's caution and warning memory, and the crew now has arrived at the 195-foot level and are walking across the orbiter access arm where the closeout crew is waiting, and the first people to be entering the orbiter, shaking hands now with that closeout team, Commander Dave Walker and pilot Ron Graby. The crew will be putting on their escape equipment here in the White Room just before getting into the orbiter. And that equipment consists of an emergency oxygen system, a parachute harness, parachute pack with automatic opener, a life raft, 2 liters of emergency drinking water, flotation devices, survival vest pockets including a radio beacon, a signal mirror, shroud cutter, pen gun flare kit, sea dye marker, smoke flare, and beacon. The commander, Dave Walker, and pilot Ron Graby will also put on their launch and entry helmets when they're in the crew compartment, but the rest of the crew should put them on prior to entering the orbiter. It takes approximately an extra half hour, about more than an hour and a half, for the entire crew to enter the orbiter and be strapped securely in their seats. The countdown continuing to go smoothly at T-minus 2 hours, 35 minutes, 20 seconds and counting. This is shuttle launch control.
MTC.
This is shuttle launch control at T-minus 2 hours, 30 minutes and counting. Commander Dave Walker has entered the orbiter now and is making his way up to the crew cabin, where he'll be getting into his seat and having the seat adjusted and the rudder pedals and other things to make sure that he's able to reach the controls on the orbiter properly. Pilot Ron Graby standing by. He'll be the second person to enter the orbiter today, and he'll be followed by Mission Specialist 3, Mary Cleve, who'll be sitting in the middeck area, and then Mission Specialist 1, Mark Lee, and Mission Specialist 2, Norm Thagard, who will sit on the flight deck. The first thing that the crew puts on normally when they're in the white room is the liner for the helmet, which contains a microphone, earphones, and connectors for plugging into the orbiter control panels. Once the helmets are on, they provide protection for the crew members' heads and faces. They reduce light and sound level in the crew compartment and provide better communications by cutting down on the level of noise during launch and directing the crew voices into the microphones so that more intelligible air-to-ground communications can be maintained during the powered phase of the flight. Each crew member is attached to an emergency oxygen system, which is used in case of failure of the cabin system to provide clean air either during the flight or after a landing if there should be hazardous gases around the orbiter. The helium tanks in the main propulsion system have completed their pressurization process, which started approximately a half hour ago. Everything continuing to go smoothly as we move towards a launch at 1:48 this afternoon. The countdown clock at T-minus 2 hours, 27 minutes, 38 seconds and counting. This is shuttle launch control.
Go ahead. Yes, sir. Step 370. Are we going for full on that? Stand by one. Yes, firm LTC. Those will be performed steps. Copy. Thank you. TTL SM 212. Go ahead. Yes, sir. I want to go ahead and report completion of step 358 through 366. And we'd like to go for step 370, please. You have a go. Thank you. CMTC. Go ahead. What was the steps that GLS just called in? That was 358 through 366. Copy. And you gave her a go on what step? 370. Copy. OTC TPE 212. Go ahead. Yeah, we were just informed by the payload people that that we can go ahead and increase the purge circuit tube temperature to 60 degrees. And we need to do that. Okay, copy that. PVD, you copy? We copy. CNSC OTC 212. CNSC go. Okay, your Talfite TACAN thumb wheel setting remains 118 X-ray. Acknowledge, and we'll take a not perform on step 446. Copy. OTC CDR, how do you rate? Read you loud and clear CDR. How many? You're loud and clear. Good morning. And good morning to you. NTD CDR, how do you rate? CDR, NTD on air to ground 1, how do you read? You're loud and clear. Good morning. Good morning, sir. Got a good ship out there today. We think so too. Houston, Atlanta, CDR, how do you read?
Atlanta, CDR, Houston, you're loud and clear. Good morning, Dave.
Morning, Frank. OTC CDR, I'll be moving my seat for a few minutes. Copy.
This is Shuttle Launch Control at T-minus 2 hours, 20 minutes and counting. Pilot Ron Graby now has entered the orbiter as well as the commander Dave Walker. And you've been hearing Dave Walker begin his checks with the through the communication system with the Launch Control Center here and with the Mission Control Center in Houston. Dave Walker is a captain in the U.S. Navy, and he was selected for the astronaut program in 1979. He flew as a pilot on STS 51A, which, in addition to deploying 2 satellites, also retrieved 2 satellites, and this was the first time that satellites were retrieved in orbit and returned to Earth. Walker was born in Columbus, Georgia, but he considers Eustis, Florida to be his hometown. That's where he grew up, and he's a graduate of the U.S. Navy Academy. Pilot Ron Graby actually will be handling a lot of the systems and backing up the flying. It's a little bit of a misnomer. The commander actually does most of the flying, and the pilot is sort of the co-pilot. However, he would orchestrate a extravehicular activity going out of the crew cabin into the payload bay if necessary. He's a colonel in the U.S. Air Force, and he flew as a pilot on STS-51J. This was the second space shuttle mission for the Department of Defense. He's a graduate of the U.S. Air Force Academy, and he earned a Fulbright scholarship to study aeronautics at the Technische Hochschule in Darmstadt, West Germany. He's a native of New York City. The next of the mission specialists to finish their suiting up will be Mary Cleve. Mary Cleve is responsible for orchestrating the secondary payloads and the photography on board the orbiter. The secondary payloads include the experiments with the mesoscale lightning experiment, and then also some crystal growth experiments. Dr. Cleve getting into the orbiter now. She has a degree in biological science from Colorado State University and a Master of Science degree in microbial ecology and a doctorate in civil and environmental engineering from Utah State University. She's also experienced in space flight, having served as a mission specialist on STS-61B. The practice which the crew received on the launch attempt last Friday obviously paying off as they are suiting up and going through their process of entering the orbiter much faster today.
Flight crew systems, DR is complete.
Mission specialist Barry Cleve will be sitting on the middeck of the orbiter during launch and the landing process.
That was DR double balls 23. All right, copy. That is complete. Okay, would you report
At this point, also, the sound suppression water tank on the pad is topped off if necessary. That tank holds approximately 300,000 gallons of water, but it's emptied within 20 seconds as water flows through the sound suppression system onto the mobile launcher deck, sprays through the engine exhaust ports at a rate of 1 million gallons a minute. The water prevents damage to the orbiter, which could be caused by the magnitude of the sound energy coming from the main engines and solid rocket boosters at liftoff. Everything continuing to go smoothly. The countdown clock at T-minus 2 hours, 15 minutes, 42 seconds and counting. This is Shuttle Launch Control.
TC, CMQC.
Go ahead.
Yes, sir. Sequence 16, step 1027. We're adding constraint Line item 71. Okay. Repeat, please. Sequence 16, 1027. We're adding line item 71. Copy.
CTLS on 212.
Go ahead.
Yes, sir, we need to request an LPSer to come out and take a look at our printer plotter at integration, please.
LPS, OTC?
Just LPS.
Yeah, can someone come out the integration console and check the printer plotter, please?
I'll send somebody out.
OTC, CMQC. Go ahead. Yes, sir. Constraint line item 69 at step 160591 has been cleared. Copy that. Thank you. DVD, OTC. DVD, 212. Yeah, just information from payloads. When we reduce our payload, they purge clear, PLT. How many? Loud and clear as well. Good morning. Good morning to you, sir. NTD, PLT, radio check. How do you read? PLT, NTD, read you 5 by. How many? 5 by as well. Good morning. Good morning to you, sir. And Houston, Atlantis, PLT, radio check.
Atlantis PLT, Houston, you're loud and clear. Good morning, Ron.
Good morning, Frank. You're loud and clear as well. OTC, TPE. Go ahead, TPE. Yeah, request to speak to CGNC over on his channel 141. GNC, OTC. CGNC, OTC. Go ahead. Yeah, can you go over to 141 and talk to TPE? Sure.
OTC CGLSN 212.
Go ahead.
Yes, sir. I'd like to report completions on step 370 through 377. All steps performed.
Copy that. CM2C, you copy? That's primitive.
Go ahead, SPM.
CMPS, OTC. CMPS, go. Yeah, we're still working on helium tank pressurization. We called that incomplete. Copy. HGD, OTC. This is CHD, go ahead. Okay, I'll give you step 381. All right, copy. Thank you. OTC, MPS. Go ahead. That was step 378, 79, and 80. Yeah, copy that, sir. Thank you.
This is shuttle launch control at T-minus 2 hours, 5 minutes and counting. 3 of the 5 crew members now in the orbiter. You've been hearing pilot Ron Graby do some of his communications checks. These are preliminary checks. And mission specialist Dr. Norm Thagard in the White Room now, waiting for his turn to put on the emergency equipment and enter the orbiter too. Dr. Thagard is a medical doctor, and he's making his 3rd flight aboard a shuttle on this mission. He served as a mission specialist on STS-7 And during that flight, he conducted several medical experiments and collected data on physiological changes associated with astronaut adaptation to space. He also served as a mission specialist on 51B. Dr. Thagard originally earned bachelor and master's degrees from Florida State University in engineering science, and then in 1966 he entered on active duty in the U.S. Marine Corps Reserve. He attained the rank of captain and qualified as a naval aviator in 1968. He flew 163 combat missions in Vietnam before returning to college in 1971 to pursue additional studies in electrical engineering and a degree in medicine. Prior to joining NASA, he was interning in the Department of Internal Medicine at the Medical University of South Carolina.
Go ahead. Okay, sir. We'll perform our approach.
There's not a lot of room in the white room, which is used for the final preparations before entering the orbiter, and therefore frequently the astronauts stand out on the walkway. You also get a better view out there, 195 foot up from the pad, and one of the spectacular vantage points along the Space Coast.
Driver switches on.
Launch Director Bob Seek has been getting a special weather update to take a look at what's happening out there in the skies. The forecast is sort of touch and go as far as how fast those clouds are going to move and what the winds will be at the shuttle landing facility at launch. There's no basic problem at the present time as far as the clouds are concerned. There's really no thunderstorms in the area, and that is expected to stay the same. We're hoping that the clouds will move toward the west and get out of the area here of the Kennedy Space Center in time for an on-time liftoff at 1:48. We do have a 64-minute window today, much longer than the 23 minutes we had on Friday, but it's still not long in terms of waiting out changes in the weather. But the forecast says that we have a 60% chance of being able to go, and we're continuing on with the count at T-minus 2 hours, 1 minute, 25 seconds, and counting. This is Shuttle Launch Control.
OTC ASP, you are broken by the weather plane. Give me a go-ahead again for 016. Okay, 016, RJDA 2B, 2A, and RJDF 2B. Driver switches on. That's complete. Copy. Right on engine valve switch on. That's complete. And unguarded ISM. Unguarded, that's firm. Thank you. CLFC, OTC. Yes, OFC, go ahead. Okay, steps 438, 439, and 40 and 41. And where? And OTC ASP, we're standing by the GPC output switch. Copy that, sir.
OTC GLS 212.
Go ahead.
Yes, sir. I'd like to get a go-ahead for my initialization at step 491. And I would need a CMQC on channel 183.
Copy. CMQC, OTC. CMQC. Okay, need someone on 183.
Thank you. And the following step is step dual interrupt notification will be activated momentarily. That's step 492.
Copy.
OTC, CLFC 212.
Go ahead.
Yeah, 438 is complete, 439 is complete. I'll verify the OMRSD. 440 and OMRSD are complete. 441 is also complete at this time.
Copy that. Asp, OTC. Go ahead. Okay, on panel 06, GPC5 output switch to backup. Stand by. That's complete. Okay, copy that, sir. And CMQC, step 443 is not performed. Copy. 446 is not performed. 444 and 45 were completed earlier. 47, 48, and 49 are not performed. And the ASP has just completed the last switch in this reconfiguration, so we are complete per 450.
OTC, CGSS.
Copy. Go ahead, sir.
Yeah, 499 and 500 complete at this time.
Copy that, thank you.
OTC, ASP.
OTC, CMQC. Stand by, CMQC. Go ahead, ASP.
Post ingress switch reconfig complete. I'll be adjusting the caution warning alarm and master alarm will be tripped.
Copy that, sir. ISL, PPE, you copy? ISL copies. PPE copies. And you can reset, sir. PPE, OTC. PPE, go ahead. Yeah, step 451. Terminate the any change switch cam monitor program. Copy, Wilco. OTC, CBSE 212. Go ahead. I want to advise you that sequence 16-0507, found that data that's not performed today. Copy that. Thank you. Thank you. CMQC, OTC.
CMQC.
Yeah, you called earlier?
Yes, sir. Did you get the fill-ins at step 446? I'll beg your pardon. That's not performed.
That's not performed.
Copy.
OTC ASP, the caution warning balance has been adjusted. That's complete.
Okay, I copy that, sir. And CMQC, that's steps 520 through 524.
Copy. OTC MS3, how do you read?
I read you loud and clear, MS3. How many?
Loud and clear.
And good morning.
NTD, MS3, is ground 1, how do you read?
MS3 is NTD. You read you 5 by. How many?
Loud and clear.
We'll have a good flight for you today.
Appreciate that. Houston, MS3, air to ground, how do you read?
Atlanta. Atlantis MS3, Houston, you're loud and clear. Good morning, Mary.
Morning.
Before you do that, go ahead and push the test on your suit valve. Good. All right.
This is Shuttle Launch Control at T-minus 1 hour, 50 minutes and counting. The Ground Launch Sequencer computer program has been started in the Integration Council here in the firing room several minutes ago. Engineers will now set up the specific tables in the launch processing system that the Ground Launch Sequencer will use as its guidelines to either let the countdown continue or call an automatic hold when it assumes control of the countdown at the T-minus 9 minute point. The status of the solid rocket booster retrieval area, as reported to the Landing and Recovery Director Chuck Henschel, is favorable. The SRB recovery ships left Port Canaveral yesterday, and they leave about 24 hours before launch. The simulation of the first motion of the shuttle has been sent to the Johnson Space Center. Range safety and firing room also test the system, which indicates liftoff. This signal also starts the clock, which keeps track of the mission time. Mission Specialist Dr. Norm Thagard moving into the orbiter now. He has been standing there waiting his turn, and one more to go. Mission Specialist Mark Lee.
MS-1, MDD, read you 5-by, how many?
Good morning, loud and clear. Houston, Atlantis, MS-1, how do you read?
Atlantis MS-1, Houston, you're loud and clear. Good morning, Mark.
Mission Specialist 1, Mark Lee, in the orbiter. He's going to be primarily responsible for the deployment of the Magellan spacecraft. He will be watching, sending the signal which turns on the spacecraft and resetting the recorders if necessary from the orbiter. Mark Lee is the only rookie on this flight. He's a major in the U.S. Air Force, and he was selected for the NASA astronaut program in May 1984. He is a graduate of the U.S. Air Force Academy and earned a master's degree in mechanical engineering from MIT in 1980. People here in the firing room, the control room which monitors all of the launch activity here, heartened by the fact that the clouds appear to be breaking up somewhat and the sun has been appearing more and more frequently. The weather really is the main concern as we go through this final couple of hours of the launch countdown. We are expecting that the weather will be moved to the mainland from off the coast by the sea breeze as it becomes more active and as it shifts. At the time of launch, it's expected that will be from just about 10 degrees south of east.
Yes, sir. The whole available timers have been configured at this time. That's steps 493 through 495.
The heaters in the solid rocket booster hydraulic control systems have also been turned on. They'll be used to start the decomposition of the hydrazine fuel, which is used to turn the turbines, supplying power to the hydraulic pumps, which in turn allow the huge nozzles to be moved for steering purposes during the flight. The closeout crew now is in the process of starting to remove some of the platforms which are used for allowing the crew to get into their seats in the orbiter. It's always a little tricky because the orbiter is in a vertical position, and the normal way for boarding it would be in a horizontal position. So the crew has to climb up special ladders. They have to use special flooring that's put in to protect what during the flight will really be the walls. Everything continuing smoothly. The countdown clock at T-minus 1 hour, 45 minutes, 14 seconds and counting. This is shuttle launch control.
Okay. It's 495A through B.
That's fine.
Okay, copy that. CGLS OTC. CGLS OTC 212.
Yeah, let's go ahead.
Yes, sir. You did perform the permanent V 495 Alpha through dog.
Yes, that's correct. We did perform that.
Okay, thank you. You copy CMQC?
I copy.
LTC, TPE. Go ahead, TPE. Yeah, I would like to speak to CHYD on HISNet 182.
HYD, OTC.
HYD copies, going to 182.
Thank you.
OTC, MS2, air to ground 1, how do you read?
I read you loud and clear, MS2. How me?
You're the same, MS2 out.
Morning, sir.
NDD, MS2, air to ground 1, how copy over?
MS2, NTD, on air to ground 1, read you 5 by. How me?
And you're the same, MS2 out. Houston, MS2, air to ground 1, how copy over?
Atlantis MS2, Houston, you're loud and clear. Good morning, Norm.
Good morning.
OTC to all systems. Verify all systems ready for crew module closeout. CMQC, that's step 528.
Copy.
And ASP, OTC.
Go ahead.
Closeout crew module for flight.
Roger, in work, and we're ready for astrocom and air to ground checks.
Okay, copy that. CDR, OTC, air to ground 1.
OTC, CDR, loud and clear.
Okay, sir, can you verify each member of the flight crew is ready to proceed with astrocom checks?
com checks, adjust your appropriate volume controls for comfort. And we'll start off on air to ground 2, and if you'll all answer up in turn, we'll go through these rather quickly.
Okay.
And flight crew, this is OTC on air to ground 2. How do you read?
Loud and clear from CDR.
KLT, that's you loud and clear.
MS1 loud and clear. MS2 loud and clear.
MS3, loud and clear.
OTC copies, and next we'll go to ICOM A. KLT loud and clear.
MS1 loud and clear. MS1 loud and clear.
This is OTC on UHF flight crew. How do you read?
CDR, loud and clear. KLT, loud and clear.
MS1 loud and clear. MS2 loud and clear.
MS3, loud and clear.
Copy that, flight crew, and that completes our checks. Thank you.
OTCS.
Go ahead, sir.
Roger, I'm ready to terminate comm with the LCC.
Copy that, sir.
To a downlist dump, or to a GTC dump, and when we do that, we will lose downlist for a few seconds.
Okay, copy that. OTC to all systems. Do you copy TPE? DPS?
This is DPS, we copy.
Okay. EPD? Copy. ISL? ISL copies. Okay.
This is shuttle launch control at T-minus 1 hour, 35 minutes and counting. A lot of discussion going on at the present time. We're coming up to a period at 1 hour and 20 minutes where the countdown could be stopped in order to uplink, in this particular case, what are known as the I-loads. These are really the computer parameters which are used for guiding the shuttle following liftoff up through the atmosphere, taking into account the various stresses that would be seen on the orbiter. they've made a decision that they will be able to go with the normal eye loads and therefore will not have to stop the clock as long as the uplink of those eye loads from the Johnson Space Center to the orbiter is satisfactorily completed, and that process is in work at the present time. The computers on board the orbiter can be updated at various times throughout the countdown, and this is one of those times when they try to have all the preparations done prior to getting further on into the count. We can actually update the eye loads at the T-minus 9-minute point, but at that point we would have to hold, and it would take a longer period than doing it right now. It appears that we will not be stopping at the 1 hour 20-minute point, but that is a possibility if the eye load update is not satisfactory, or if there is a determination that the normal one would not be able to be used today and they want to use an alternate eye load update. As we come up on the T-minus 1 hour 30-minute point in the count, you'll hear the booster test conductor directed to perform a calibration of the solid rocket booster chamber pressure transducers. These transducers measure the pressure in the thrust chamber at the nozzle, and this information is used to tell the computer when to separate the solid rocket motors. The separation procedure begins when the chamber pressure falls below 50% of normal. At the 1 hour 30-minute point, the booster engineers will also go through the test of the rate gyro assemblies, during which they simulate the effect of flight as far as the rate gyro is concerned with the magnetic field, and then measure whether or not it is reading properly. Up in the White Room on the 195-foot level of the pad, the closeout team is in the process of getting ready to close the hatch on the orbiter. The astronaut support person is gathering together the materials which are needed inside the orbiter during the entry of the crew and in preparation for them to get on board. However, are not needed during the flight. The work going along ahead of schedule slightly. The crew all on board and in the process of beginning their various types of communications checks. The eye load process underway now in the updating of the computers. The countdown clock at T-minus 1 hour 31 minutes 9 seconds and counting. This is shuttle launch control.
Atlantis, Houston, we're ready for air-to-ground voice checks. We'd like CDR and PLT configured for air-to-ground 1.
Okay, Frank.
Atlantis, CDR, Houston on air-to-ground 1. How do you read?
Houston, Atlanta, CDR, loud and clear.
You're loud and clear also, Dave. PLT, how do you read?
Houston, Atlanta, PLT, you're loud and clear.
You're loud and clear also. Configure for air-to-ground 2 voice check. Atlantis, Houston on air-to-ground 2. CDR, how do you read?
clear, Frank.
You're loud and clear also. PLT, how do you read?
PLT has you loud and clear at ground 2.
Roger, you're loud and clear also. Configure for UHF. Atlantis, Houston on UHF. How do you read CDR? You're loud and clear also. PLT, how do you read?
PLT has you loud and clear UHF.
Roger, you're loud and clear also. All flight crew configure for SIMO voice check. Atlantis, Houston, SIMO, how do you read CDR?
Houston, Atlanta, CDR, loud and clear.
Roger, no echo problem, right, Dave?
Nope, sounds perfect, Frank.
Roger. PLT, how do you read?
Houston, Atlanta, PLT has you loud and clear, SIMO.
Roger, you're loud and clear also, Ron. MS1, how do you read?
MS1 has you loud and clear.
Roger, Maggot, you're loud and clear. MS2, how do you read?
Houston, Atlantis, MS2 has you loud and clear, Frank.
Roger, you're loud and clear also, Norm. MS3, how do you read?
Houston, Atlantis, MS3, you're loud and clear.
Roger, you're also loud and clear, Mary. Y'all have a good flight.
All personnel on,
Thank you, Frank. We intend to.
all personnel channel 212 in the firing room, be advised there will be a momentary loss of downlist and DPS OTC.
DPS, go ahead.
Okay, how about your orbiter GMT and net delta adjust? Would you be ready at this time to pick that up?
We'll pick that up per the clock.
Copy that.
And the downlist dump has already occurred. That's complete.
OTC CGNC? Go ahead. Yeah, if I could get a CMQC on channel 141 in preparation for step 593 and 594. And if I could get you go ahead on those steps per the clock. Okay, you have a go at this time per the clock and CMQC OTC. CMQC OTC 212.
CMQC.
Right, we need your support on channel 141, please.
That's right. OTC, CWS.
Right, double S.
Yes, sir. I'd like to verify step 526.
526, okay, thank you.
OTC, OBCC.
Go ahead, OVCC.
Yes, sir. Seal leak test and continuity check were both successful. We're ready to proceed with cabin leak check.
Okay, we copy that.
That'll be with ECL.
That's firm. And CMQC OTC.
CMQC, go ahead.
All right, step 599.
Copy.
OTC ECL.
Go ahead, ACL.
Can I get a CMQC on 143?
All right. CMQC, OTC.
Copy 143.
And ECL, OTC, 212.
OTC ECL.
Right, you ready for a cabin leak check at this time?
We're ready.
Copy that. CDR, OTC, air to ground 1.
CDR, go.
Okay, I'll be picking up on the cabin leak check momentarily on panel L2A1.
And there?
The cabin vent, the vent ISO switch open until the vent ISO talkback open.
That's complete.
And the vent talkback is closed.
So that talkback is closed.
Copy that. ACO, step 602.
ECL verified.
Copy.
OTC, HYD.
Go ahead, HYD.
Yes, sir. I'd just like to inform the crew of a water spray boiler anomaly.
Okay, stand by just one, please. ECO, OTC.
Yes, ECL.
Okay, you have a go on cabin pressurization and cabin leak check for step 603.
Please, copy. It'll be on work. OTC, CVFS.
Go ahead.
Yes, sir. Can I talk to QC for just a second? Yeah, let's go over your channel. We're doing something. What I'm trying to find out is if there is a DEV that they have recorded to volume 2, sequence 16, step 5, 16.
You copy CMQC?
Copy. OTC, Phil.
Go ahead.
Yeah, we'd like to have the CDR monitor for a mass alarm here when we bring pressure up and let us know when that happens.
Copy that. CDR, OTC.
CDR, will go.
Copy.
That's affirmative.
CHYD, OTC.
HYD.
Okay, and CDR, OTC.
CDR, go.
Okay, go ahead, HYD.
Okay, what we've got here is, as we discussed yesterday in the L-1 day briefing, the way our temperatures are on the spray boiler right now, we will not get a spray boiler okay, which adds to give you your AQ HYD ready to start talkback on panel R2. So the way things are right now, you would not get a gray talkback on system 2. And when we go to internal power later, if we get a
This is shuttle launch control at T-minus 1 hour, 20 minutes, and counting. The closeout team up there in the white room on the 195-foot level of the pad are in the process of completing closing up the hatch. Once they have it sealed, which they have at the present time, then they remove the handle that's used during the period that it's open, and they put insulation plugs in the holes to protect it from the heat that it might encounter primarily during re-entry. That process underway at the present time. Commander Dave Walker has been asked to perform the cabin leak check, and that is in work. And the crew was being briefed on the problem with the water spray boiler temperature, which has been talked about periodically during the last few hours of the countdown. This is not expected to be a problem, but they may not be able to see a temperature on that because it would be off scale. They've taken a look at at all of the functions and the reasons, and have increased the temperature in the area where that water spray boiler is located to try to get the thing back on scale where they can read it properly. But the temperature actually is not a problem as far as the operation of it's concerned, unless it should get too cold and freeze. The mission management team has discussed the water spray boiler, and it appears that that will not be a problem as far as the launch is concerned today. The weather continuing to improve here at the Kennedy Space Center, as the weather people thought it probably would. Most of the clouds now in the pad area are gone, and the clouds continue to move in a westerly and slightly northerly direction. At the shuttle landing facility 4 miles west of the pad, the convoy which would support the shuttle orbiter should it have to return to the landing facility is being positioned for such a contingency. The convoy is made up of a number of vehicles, including a purge truck which flows air through the vehicle to ensure there's no buildup of toxic gases, a cooling vehicle which provides freon for the orbiter's coolant system to reject heat produced by electronics and other systems on board, a special white room and stair truck for the astronauts to use in exiting from the vehicle. Also, personnel wearing special self-contained breathing suits called scape suits are on hand. They are not suited up at the present time, but they would be the first to be on the scene in case of a landing, using instruments to sniff the atmosphere around the vehicle to make sure there were no toxic propellants escaping that might endanger the landing support crew or the astronaut team when they exited the vehicle. We have passed the 1 hour 20-minute point, which was an emergency hold period. The eye loads, which we discussed earlier, have been uplinked to the vehicle, and they decided that they could go with the standard eye loads that they had planned for today. If the wind shift occurs in the upper altitudes, we would be able to upload a new alternate program at the T-minus 9-minute point. However, that's not expected. The determination of what computer programs you place in the orbiter to use for steering up through the atmosphere is based on information coming back from various types of balloons. These balloons are launched periodically, starting a day before the mission, and then becoming more frequent in the last 6 or 7 hours. The information from them run through a computer to see the directions and the velocity of the winds as they go up. The Gymosphere balloons, which are used to go up close to 60,000 feet, and we have seen top winds at about 90 knots around the 40,000 foot level today. However, very little wind shear, which is winds that are blowing in different directions at different altitudes. So we appear to have everything going along very smoothly at the present time. The crew in the cabin, the hatch closed, cabin pressure underway, and the weather appears to be cooperating with us, and the countdown clock continuing at T-minus 1 hour, 14 minutes, 20 seconds and counting. This is Shuttle Launch Control.
during this quiet time, I'll pass along to you, the payload community gave us a goal to not lower the per circuit 2 temperature, so we'll stay where we're at 60 degrees right through T0.
Okay, copy that, sir. Thank you.
CMQC.
Go ahead, sir.
We don't have any verification on that at this time.
Copy.
OTC, CVFS.
Go ahead, sir.
Yes, can I please get QC over to 152?
CMQC, OTC.
CMQC.
Someone on 152, please.
Copy.
This is shuttle launch control at T-minus 1 hour, 10 minutes, and counting. The pre-flight calibration of the inertial measurement units, which started back at the T-minus 5 hour point, has been completed. The systems engineer at the Guidance, Navigation, and Control Council reports that he's ready to proceed with the IMU attitude determination as soon as the Greenwich Mean Time adjustment is complete. The mission timer can show either Greenwich Mean Time or mission elapsed time and can be adjusted to within 1/1,000,000th of a second, either by ground command via uplink through the onboard computer or by the flight crew through their use of their flight deck display and control panel keyboard. The inertial measurement units are used to tell the guidance systems on the orbiter where it is in relationship to its launch pad here at the Kennedy Space Center. Each IMU contains 2 accelerometers to sense accelerations of the vehicle and 2 gyroscopes to provide a stabilized 4 gimbal platform to provide attitude and velocity information with respect to known coordinates. The navigation system used by the shuttle uses a standard reference point that is based on the position of the stars as they were at the time of the vernal equinox in the year 1950. The complicated process of aligning the IMUs begins when the units are calibrated during the early part of the countdown. The next step, the one about to be accomplished, is to make the transition from a calibration into an operational mode. Then at the T-minus 61 minute mark, the IMUs transition again into their pre-flight alignment mode, which will continue until the units are set to inertial at T-minus 20 minutes. In orbit, the IMUs must be realigned periodically, and this is done with the 2 star trackers. The star trackers are mounted on the same fixed platform as the IMUs in the forward section of the orbiter. The astronauts select 2 stars from the 50 stars in their catalog, and they pick stars that are about 90 degrees apart and use this for updating the alignment of their navigational system as they circle the Earth. The countdown clock continuing at T-minus 1 hour, 7 minutes, 18 seconds and counting. This is shuttle launch control.
OTC, go ahead. You can notify pad leader to continue the hatch closeout per off report setup 20 at this time.
Copy that. OBCC, OTC. OBCC, OTC.
Go ahead, OBCC.
Okay, for ECL, you can continue your hatch closeout at this time.
We copy. That's in work, sir. Safety wires going on the cap now.
Thank you. CGNC, OTC.
Go ahead.
Yes, sir. Are you going to be ready for your pre-flight align by the clock?
Will do.
Okay, I'll give that to you by the clock, 6:05.
Copy.
CCME, CSME, OTC. CCME. Yeah, you ready to go ahead and set up your printer plotters?
We can do that. Just SME.
You ready to set up printer plotters now?
Copy that for 610.
Yeah, that's affirmative. Okay, we'll get LPS in.
Okay.
LPS, OTC.
This is LPS.
Yeah, we want to go ahead and put step 10 into work. 610, I'm sorry.
Copy 610. We'll get those plotters online.
Thank you.
OTC ECL.
Go ahead.
For step 679, the crew module press and cabin leak check is complete, and we're ready for cabin vent redundancy config.
Copy that.
CDR, OTC. CDR, go. Sir, I'd like to go ahead and perform our cabin vent redundancy configuration. Okay, I'm ready. Okay, panel L2A1. On there. Vent isolation switch closed until the vent isolation talkback shows closed. That's complete. Copy that. And vent switch open until vent talkback open. Say the cabin vent is open and the talkback is open. Copy that. Thank you, sir. ECL, you copy? ECL copies. OTC, OBCC. Go ahead, sir. Top support set 20 is complete. Copy, thank you. Okay, you verify the ECS damper is closed. That's verified. Copy that. That's step 706 CMQC. And CMQC, how are we doing on our verification of out support setup 2? Still in work. Copy.
This is shuttle launch control at T-minus 1 hour and counting. The commander, Dave Walker, has reported that he has completed the first of the cabin leak checks. During these leak checks, the commander closes the cabin vents and the cabin slowly pressurizes from its normal sea level pressure of 14.7 pounds per square inch up to 16.7 pounds per square inch. And as the pressure increases, the environmental control engineer in the firing room monitors the status of that test. The higher than normal pressure causes alarms in the cabin to go off, and that also serves as a test of the cabin's caution and warning system. Additional cabin leak checks are performed later in the countdown. The Eastern Test Range safety hold fire checks have also been completed. These things being completed a little bit early today as the launch team goes through the countdown with very little problems. And we've heard from the operations manager, Bob Crippen, that the water spray boiler concern, which had to do with the temperature of that water spray boiler, has been improving continuously. the concern really has to do with being able to tell what temperature it's at just prior to starting the auxiliary power units. It's used to cool those units when necessary, and it does that by spraying water on the surface to carry away the heat. During the earlier part of the countdown, the water spray boiler was colder than it normally is, and as a result, the temperature was off of the scale of the instruments that measure that. It was not considered to be a major problem, but it's always nice to have it working exactly right. Continuing to watch the weather, we've been informed that right at the moment we have a crosswind violation as far as return to launch site abort is concerned at the shuttle landing facility. That crosswind up to about 14 knots and gusts. Where the weather, of course, continues to change as the ocean breezes come into play as we get into the afternoon, and the heating by the sun changing the direction of the wind slightly, and also the cloud layers. The pre-flight alignment of the inertial measurement units was started on time just about 3.5 minutes ago. The pre-flight alignment will be completed during the hold at T-minus 20 minutes, just before we put the onboard computers into their final countdown configuration. The pre-flight alignment cannot be completed more than 10 minutes prior to the computer transition to what is known as Ops 1, which occurs when the team comes out of the T-minus 20-minute hold. However, if it's delayed longer than the 10 minutes allowed, then the pre-flight alignment must be performed again. The safety officials have confirmed that fire and rescue personnel will be on station at the shuttle landing facility and just outside the pad blast danger area by the T-minus 30-minute point.
Go ahead.
The countdown continuing very well as we move towards a launch at 1:48 p.m. Eastern Daylight Time. This is the second launch attempt for STS-30 and the Magellan spacecraft to Venus. The first one last Friday was stopped because of a problem with a recirculation pump on engine number 1, which is used for moving the liquid hydrogen through the engine area back into the external tank to keep the temperature and condition of that suitable for the start of the engines. That pump was changed. They also changed a 4-inch recirculation line, which was a line that carries the liquid hydrogen back to the external tank. Although it was suspected that there was a leak in the outer chamber of that line, it turned out that there was not, and that it was not the problem once it was understood that it was originally thought to be. Things going along quite smoothly. The countdown clock at T-minus 54 minutes, 50 seconds and counting. This is shuttle launch control.
We need a not performed option on that step.
Yes, sir, that's page 336 of volume 1, 27.
Okay, copy that. Stand by 1. Stand by, please. RCRE, OTC. RCRE? Yes, sir. Can you pick up step 629 at this time?
Okay, step 629 is complete.
Copy that. Thank you. AFM, OTC.
This is AFM.
Yes, sir. I don't know whether you copied a minute ago on our op support setup 2 structural configuration for launch verification. Apparently we need a not performed option added to one door that was closed out for flight on the first run and stayed that way. I guess I'd like to go ahead and get on that concurrence to go ahead and work this with a D to follow adding a not performed option there.
What door are you talking about?
Standby 1. CMQC OTC.
CMQC, let me see if I can find that again here.
Okay.
Door 40, I'll move door 45. Okay, it's a structures door, not an MEQ.
Okay. PPE OTC.
PPE, go ahead.
Yes, Steve, did you copy, we need a not performed option added on putting the 45 door on this time? That's holding up our verification of the structural configuration on support setup 2.
Okay, yeah, we'll take that action. We'll write the B for you.
Thank you, sir. And CMQC has the details here.
OTC ECL.
Go ahead, ECL.
I can give you step 697. Final cabin leak check is complete.
Copy that, ECL.
And for step 698, record a TPDT of 0.004.
Copy 0.004.
We're ready for cabin vent 699.
Okay, copy that, sir. CDR OTC. CDR, go. Yes, sir. We'll want to go ahead and work our cabin vent, and you may get klaxon and master alarm, and if so, reset. And on LCDR, we'll go. Okay, L2A1. On them. Okay, vent isolation switch. Open until vent isolation talkback open. Okay, you're going to open the vent ISO until it's open. Okay, we've reset the clock set. Copy that. LDCC, this OTC. Copy that, sir. Okay, and ECL 702. ECL verified. Copy. CDR, verify cabin pressure decreasing. Cabin pressure is decreasing. Copy. And CDR, let me know when you show open. Okay, sorry, we've got open talkbacks on both the vent ISO and the vent, and the cabin pressure is decreasing as expected. Okay, copy that, sir. Thank you. ECL, OTC. ECL. Okay, stand by to give pro words closed cabin vents on channel 212 if a decrease in PPO2 below baseline is observed on CRT page B. ECL, copy. CGLS OTC. CCSE OTC. CCSE. Okay, need you over on 232 for S-band and RCRE OTC. RCRE. Need you over on 232, sir. OTC CDPS. Go ahead. 683 and 684 complete. Copy that. DPS OTC. DPS, go ahead. Yes, sir. Step 690, your launch countdown sequence program by the clock at 44 minutes. Okay.
This is shuttle launch control at T-minus 44 minutes, 40 seconds, and counting.
You have a go.
The range safety officer has begun a final network verification test of the range safety command network. The terminal count range safety closed loop check begins at the T-minus 45 minute point.
Copy that. Thank you.
We've just heard the launch team talking to the Merritt Island tracking station. They are going through the high-powered reconfiguration of their antenna systems. However, they actually won't be going to high power until the T-minus 11 minute point in the countdown. The reason for that is that we discovered during the first count on the Magellan mission last Friday that when the Mila tracking station transmitter is turned to high power, that the receiver on board the Magellan spacecraft is saturated and locks up. In order to prevent that from happening earlier in the count, Mila will not be switched to its higher power mode until the T-minus 11-minute point. If it causes a problem, actually the saturation of that receiver is not a problem once it gets into orbit at all. The Magellan spacecraft actually is capable of a great deal of self-monitoring and fixing of problems by itself. In the rare cases where it is not able to fix a problem, it puts itself into a sleep mode while the ground controllers think about what that problem is and then wake it up and tell it what it needs to do next.
OTC, CMQC. Go ahead, sir. Okay, op port setup 2 is complete.
In the range safety closed loop check, which is presently underway, the test will verify that the shuttle's range safety receiver responds correctly to commands sent from the ground support equipment located in the mobile launch platform using the actual flight codes. Inhibits are placed in the system to prevent inadvertent firing of the range safety devices during this particular test. The ground launch sequencer mainline computer program has been activated and now is actually processing data. This program will monitor various key commands and systems prior to its assuming control of the countdown at the T-minus 9-minute mark. Everything continues to look favorable for an on-time launch of STS-30 at 1:48. We are continuing, of course, to monitor the weather. We have had a violation of the crosswind constraints at the shuttle landing facility, but are not expecting that will be a problem at the time of launch. It is just slightly over the limit, crosswind of 14 knots. The 14 knots is a problem only when it's a direct crosswind. When it's a crosswind component because of a higher level in the wind coming down the runway from the nose, then 14 can be acceptable under some conditions. We're coming up on the 40-minute point in our countdown. The leak checks of the cabin have been completed, and Commander Dave Walker has opened the cabin vents to bring the pressure back to its normal level. During the time that the pressure check is completed, air is vented at a high rate into the cargo bay, and a redundancy check is done to ensure that not only is there a single valve that is protecting the cabin, but also a redundant valve or a backup valve. The countdown clock at T-minus 40 minutes and counting. This is shuttle launch control.
RF set source verification. I copy. LTC, PPE 212. Go ahead, PPE. Yeah, request CPROP and CMPS to 161, please. CPROP, CMPS, OTC. CMPS, OTC. Okay, this is CMPL to CMPS. They're going over to 161. Copy, thank you.
OTC, CPVD 212.
Go ahead, PVD.
We're going to request permission to reposition vent doors 1 and 2 right-hand side. That'd be step 787 if the white room is clear.
White room is clear, sir.
Okay. And if we have you go, we'll put that step in work. will you please notify AFM that they may see a forward MCA ops indicator change?
Okay, AFM, OTC?
Yeah, CAFM copies.
Okay.
OTC ECL.
Go ahead, ACL.
Cabin venting is complete. We're ready for a cabin pressure reading. Step 770.
Copy that. CDR, OTC, air to ground 1. CDR is with you. Could you give us a cabin pressure reading? Cabin pressure looks like about 14.9 to us. Okay, ECL, you copy?
ECL copies, and we record 14.66 for step 772.
Copy. And CDR on CRT3, what is your cabin pressure show? Well, you're not going to get a good number there because we haven't got the BFS up yet, OTC. When we get the BFS, we'll have the right display. Copy that. Yeah, we do have to have BFS. We'll wait on that.
CPVD.
Go ahead.
All vent doors are in normal purge configuration for step 789.
I copy.
CMQC.
Go ahead.
Yes, sir. Step 16, 1027, line item 71 has been waived.
Copy. CDR, OTC, air to ground 1. CDR, go. Sir, go ahead and give you a go to perform your pass CFS transfer prep.
This is shuttle launch control at T-minus 35 minutes and counting. In just a couple of minutes, Commander Dave Walker will perform the test of the transfer capability between the primary ascent computer redundant set and the single backup flight system computer. There's 5 computers on board the shuttle, and 4 of them act as what's called the redundant set, or the 4 running together which back up each other, and then a single computer is used as the backup flight computer. This test verifies that critical guidance